All right, so this video is going to cover the idea of a radical. And so a radical is a fancy name for the symbol for square root. And a lot of people don't go beyond the square root, but we are going to look at other roots. Let's look at the first thing I want to think about is just looking at a square root of like 25. What does that actually mean? It's undoing a root. Like a square root is undoing a second power kind of idea. So I could think of this as this is 5 squared, and this is like a 2 out here on the root, but I don't write the 2 when it's a square root or a 2 root. And so basically this undoes this, so the answer is 5. And that's the idea or the logic behind it. So if I have a third root of 8, then I have to think about, I had to look at the square on this one. I have to look at the third power for this one. So what to the third power would equal 8? It's going to be 2 to the third power. So when we take away the radical, the third root will take away the third root, and we'll end up with a 2, or a third power undoes the third root kind of idea. Excuse me. So then we know we can't have a negative under here because anything squared is positive. But on a third root you can, because it's 3 of them. So if I would have had the third root of a negative 27, well, what number times itself 3 times would give us 27 is going to be 3, but it would be a negative 3. So if you think about it, if you have negative 3 to the third power, that's like negative 3 times negative 3 times negative 3, which does end up being negative 27. You can't end up with that negative on a square. It just doesn't work. That's where we get into the imaginary numbers. All right, so then we end up with like a negative third on this one. You can also do fractions. So if you have a third root, let's just do the 8 over 27 because we've looked at those numbers. You can break this up and do the third root of the top and bottom separately. So the third root of 8 is going to give you 2 because 2 times 2 times 2 is 8. The third root of 27 gives you 3. So you can look at each top and bottom separately and simplify the ones that you can. You can also estimate these on the calculator. So here's mine. I always have to make sure it's like up a little higher so that you can actually see it. Okay, so I have a third root power or power root right here, and it's got x third root. So if I have something like I want to see the third root of 27, I'd hit 3 and then the button, and that's saying 3 to the x, or the third root of 27, and then let's see what it gives me. It should give me 3. So what if I want the third root of a really big number? You can then do it and estimate it or get your answer off of the calculator. It does fourth roots, square roots, any kind of root you want to do. Okay, you just look for that key. All right, so you can estimate them with a calculator. What if I threw a letter under here? People always make the letters harder than they are, but they're really not that hard. Alright, so actually I think they're easier than numbers. So if I have the fourth root of x to the 8th, what am I really saying? Well, I'm saying basically how many groups of 4 do you have in this 8? Or divide 8 by 4 and you'd get 2. So you'd have 2 groups of the fourth root in there that you could take out. So you end up with x squared. You basically end up dividing them. What if I had the square root of x to the 10? What will I end up with there? Well, I'm going to end up with, this is like a 2. 10 divided by 2 is 5, or half of them. So squares are half, right? And then the other powers you have to divide and get the groups of them. Excuse me. All right. Then this section, it goes over basic roots or radical ideas and estimating them. And then it goes over graphing them. So let's look at the general graph of this sucker. So this is graphing a radical. Let's look at, this is called the parent graph, and I'll put it in function notation because that's the general way you see it. This could be a y or an f of x. This is the parent graph, and all you do is figure out numbers that are on this. So you put in any x. Well, shoot, let's put in 0. What is the square root of 0? Well, it's 0. What if I put in 1? What is the square root of 1? 1. Then do I want to put 2 in? Because the square root of 2 is, 1 point something? No, let's pick numbers that you can actually take the square root of because they're pretty, like 4. 4 square root of 4 is 2. 9 square root of 9 is 3. And then let's graph this here and see what this graph is going to look like. Right. So 0, 0 is here, 1, 1 is here. Now typically you're going to have both of those points unless it's rotated or moved, translated somewhere else, because 0, 0, the square root of 0 is always 0, and 1, 1, the square root of 1 is always 1. And then 4, 1, 2, 3, 4, 2 is on this graph, and 4, 5, 6, 7, 8, 9, 3. And you can see that this graph looks like this. So the radical typically looks like half of a U starting here and going up. Now what happens, well, and let's list the domain and range real quick for this one. Domain, okay, what x values can I put in? So for the graph, look at where the x stops. We don't see a graph over here at all on the negative because I can't put a negative in. So I'm restricted by being above 0. So my domain of the parent graph is going to be from 0, including 0, because you can take the absolute value of 0, all the way to infinity. I can keep going. What's the range? Alright, so the range, you look this way, right? So we can see that the numbers start at 0 and that they'll continue to go up, right? So they'd be up here. The graph would keep going up, so we can get any y, but we cannot get a negative. If you can't put a negative in, you can't get a negative out, so the range is the same. From 0, including 0, so you have the square bracket, to infinity. This is in interval notation, which is super common at the college level. The high school level, you could put x is greater than 0 or equal to 0 on, and then y is greater than or equal to 0. So you could include just the m, the symbol for greater than or less than, if you're in high school, typically. Let's look at what happens. I'm actually going to do this one in Graphing Calculator Online. Oops. Okay, so my HRW, this is my graphing calculator for the high school, but it works really similar to what any graphing calculator you download or you use in the TIs as well. Okay, so graphing calculator. All right, let's see what happens when we have something like the square root. So here's the square root symbol. We know of x. We know that this graph is going to look like this. We just saw that, and here's points. But what if I, inside the parentheses, add 2? What's it do? Ooh, it moves you to the left 2. So you can see that when you add 2 under the radical, it moved you to the left. What if I would have subtracted 2 there? What do you think that would have done? It would have moved you to the right. So when you put a number in with the x in the radical, it moves you left and right, a translation or a shift to the left or right, opposite of what you'd think. Positive moves you negative, negative moves you positive. Okay, what if I would have put that number outside of the radical? It moves you up. And notice positive moves you up and negative moves you down. So you can see the shift of the numbers. All you're doing is shifting this same graph around. Okay? And this is all for a square root. I don't think I can do a third root, darn. I can do a third root a kind of different way. That's okay. And it's okay to show you this too, but I can say x to the power is like a caret, this one here on this one, or above the 6. And I'm going to say to the power of 1/3. Let's look at the third root. This is another way to write the third root. Oh, it didn't do it right though. X to the power. It doesn't include this part of the graph. Oh well, I don't have a third root in this one, so I obviously it's not graphing this one right. I'm not sure why. I don't know if I added a parenthesis around this, if that would okay, graph it right or not. No, still not graphing this one right. Oops, I forgot to graph. Fourth graph. Yeah, still not quite graphing. So the third power, and I must be missing something. It should have a negative portion because you can take the negative of a third root. So I guess I can't show you the third power on the calculator, but anyway, I'm going to go back to my page here. You can basically graph yours by listing points, but you can see that what the numbers are doing and actually figure out the shifts based off that parent graph. That's also going to shift your domain. So pay attention to where your domain and your range are shifting based off your graph. Okay, and that's about all I'm going to show you on the basic radical.